All right, kids, this is the second class in naming compounds. This is called naming simple monoatomic ionic compounds. That's a lot of syllables. Monoatomic means one atom, and ionic compounds mean that the atoms form into ions and bond together. Monoatomic refers to when metals on the periodic table or nonmetals on the periodic table turn into ions. So you can always have at least one metal atom and one other nonmetal atom. There is something called polyatomic ions that are groups of atoms that act as a single ion. We're going to get to that another day. You got to have your reference tables, okay? And you're going to have to open it up to the periodic table. And here's mine. I have mine. I don't need it, but you do. This is a picture of a big chunk of NaCl, sodium chloride. It's just a big chunk. It's probably bigger than my head. Sodium chloride exists as a solid, and it actually is pretty clear. You can't really see it clear. When the crystals are really small, they look white in a salt shaker. But when they're really big, they're actually a bit clear. Pretty cool. All right. An ionic compound is going to form when a positive cation, which are the metals that lose electrons, they lose negative electrons, become positively charged. They're called positive cations, are going to come together with a negative anion. Now, anions are when a nonmetal would gain the electrons that are transferred from the metals. So it's perfect transfer. And so the positives and the negatives come together to make a neutral compound. 26, cations form when metals transfer electrons to nonmetals, which simultaneously form negative anions. You can't have one without the other. There is no jar of sodium ions. There is no jar of bromide ions or anions. You got to have them both together. They form when the metal transfers or loses the electrons. They don't really lose them. Lose is a bad word because we know exactly where they are. They go into the negative side. They form into anions. Opposites attract like love, so a positive cation and a negative anion are going to be very attracted together. Now, there's always going to be a perfect transfer of electrons. Perfect. So if a metal loses one electron, it only has one electron to give. If the nonmetal says, hey, I need 2 electrons in order to form into an ion, I need to get 2 more electrons, well, then it's not going to work, okay? It's either perfect or nothing happens. Now, you already know this. You already know some chemistry and some of the rules. NaCl, which is the white stuff you put on French fries, is called sodium chloride. It doesn't have any other silly names. You don't call it sodium chlorine. You don't call it chlorine sodiumide. Sodium chloride. And you call it that because there's rules into how to name an ionic compound. Here are the 2 rules there in red, 30 and 31. The first rule, the first name rule, the rule for the name for the first name, is you always name the cation or the metal first, and you call it by its atomic name. So Na is sodium. Even though it's a cation, we still call it sodium. It's the sodium cation, but we just say sodium. The second name rule, the second name is always the anion. In this case, it's chlorine, which is going to become negative, but we change that name to end. Instead of chlorine, it's chloride. Now, on the periodic table, there's a limited number of anions that can form, a limited number of what we call the monoatomic anions. And in 32, list them all. I'm going to say them. You listen. F, fluorine becomes fluoride. Cl, chlorine becomes chloride. Br is bromine. These are all in group 17. Br, bromine becomes bromide. Iodine becomes iodide. Oxygen would become oxide. S for sulfur is called sulfide. Now, Se, that's an element that comes up sometimes, but not so much. It's a nonmetal, and it makes something, selenium becomes selenide, but you're not going to see that too often. Nitrogen, N, becomes nitride. P for phosphorus, that's a funny one because it's pH. P for phosphorus becomes phosphide. And in As is actually the element arsenic. It would become arsenide, arsenide. So 2 of them, we're not going to see too much. We might see them on some practice, but in all honesty, you're not going to see them in your life very often. It becomes more of a practice. So those are the names. I just gave them to you, but now you can see what they look like. You might need to hit pause and write them all down. All right? Now we're going to name these compounds. Always say the name of the metal first, and the metals first all the time in these formulas. I wrote these formulas. The formulas are actually correct. We're going to learn how to write the formulas. How come they don't have any 2s or 3s, or we never write the number 1 because we are number 1. But Li is a metal, element number 3. Bromine is a non-metal, element number 35. We would call that one lithium bromide. The next one, Ca, is Charlie Arbuso, but we never say it like that. We say calcium. In this case, it would be calcium oxide. Be is element number 4. That's a hard one, all right? It's called beryllium, Bes for sulfur. So it's beryllium sulfide. MgO, we saw that in the lab, all right? I showed it to you. It's a white crystal powder that comes out when you burn the magnesium in the air. Magnesium and oxygen combine to form something called magnesium oxide. Cs is element 55, combining with element number 9, cesium fluoride. Sr is a really cool one. I think it's 38. Yep, Sr38, strontium sulfide. Strontium is underneath calcium on the periodic table. And the last one, Alp, is alp. No, it's not. That's a bad joke. Al is aluminum and P is phosphorus, so it'll be aluminum phosphide. And here are all the names written out for you. Again, you might have to hit pause to write these down. You have to spell stuff right too. The first names are the elements for the metals. The metals always go first. Those names are on table S. And I wrote down, and you wrote down in the notes just a few minutes ago, all of the monoatomic anions that are possible. You just got to figure out from the symbols what element it is and change the ending to IDE. It would never be lithium bromine or calcium oxygen. We changed the second name to IDE. How do you remember that? NaCl is sodium chloride, and you already know that. You already know that. That's the rule. Now, what if we combine something like calcium and chlorine? How is that going to work? Calcium is going to make a positive 2 ion. How do we know that? Well, on the periodic table, calcium has a 2882 electron configuration. Calcium is metal. Metals have to lose electrons so they become isoelectric to a noble gas. Now, the closest noble gas to 2882, to number 20, would be number 18, argon, 288. So it would have to lose 2 electrons. Calcium has to lose 2 electrons, become a positive 2 ion. Chlorine, which is element number 17, 287, is a nonmetal. How many electrons does it have to gain to become isoelectric to noble gas? It'll also be isoelectric to argon, 288. It's got to gain 1 electron. So the chlorine atom has to gain 1 electron. Now, 2 electrons come out of calcium and only 1 gets picked up by chlorine, and 2 and 1 doesn't work. This is a problem. We're going to deal with that, right? So this is what we do. In a 2-to-1, we can't make it a 1-to-1 ratio. If calcium, which has to give up 2 electrons, wants to combine with chlorine, and chlorine can only take 1 electron, that's not going to work. Calcium cation must transfer 2 electrons. The only kind of cation it can make is a positive 2. The only way that's going to work is if we do 2 chlorine ions at the same time. 1 calcium and 2 chlorines at the same time. It's kind of like 1 thick piece of bologna and 2 pieces of bread make a sandwich. In order to make calcium chloride, you're going to have 1 positive 2 ion and 2 negative 1 ions, and they form in a 1-to-2 ratio. And that's actually pretty cool. Now, we're going to look at these ion charges. They're very easy to figure out. We're going to figure a lot of them out. They, write them down, and they're easy to understand. But once the ions are written down next to each other, I'll show you an easy way to crisscross them so you can always figure out the formula. In fact, here it is now. If you write the calcium cation, which is a Ca+2 superscript, right next to Cl, which is a -1, the chlorine wants to gain 1 electron, the calcium wants to lose 2 electrons. These are called the ion charges, and the calcium is positive because it loses 2 negative electrons, and the chlorine is going to become a -1 ion when it gains 1 electron. If you crisscross the numbers, put the 2 from the calcium with the chlorine and put the 1 from the chlorine with the calcium, crisscross them, you have Ca1Cl2, and we don't write 1, so it's going to be CaCl2 for the correct formula. This is called the crisscross method. I don't want to think about it too hard, but I got to write the formula correctly.com way to do things. Crisscross method. So we're going to do a whole bunch of these, and we're going to name them. So let's look at this first one. The cation, Na+1, that's called the sodium cation. Sodium makes a +1 ion. How do you know that? Sodium has a 281 electron configuration, and we wrote the +1 on a different reference table. Sodium loses 1 electron. Phosphorus is element number 15. It is a 285 electron configuration. It's got 5 electrons in the outer orbital. It's got to get to 8 so that it becomes isoelectric to argon. So the phosphorus anion, the phosphide, has to gain 3 electrons, which makes it a -3 ion. So when you have a +1 and a -3, and you crisscross, the 3 from the phosphorus hooks up with the sodium, and the 1 from the sodium hooks up with the phosphorus, and we never write positive and negative in formulas. So in order for this to work, to make sodium phosphide, you're going to need 3 sodium cations to hook up with 1 phosphorus anion. Each sodium gives away an electron, that's a total of 3, and each phosphide says, give me 3, then it balances. Now the second one's tricky. The second one is tricky. John Dalton, he said simple whole number ratios. And if you crisscross these, it's going to be Ca2S2. 2 to 2. You can do it like this, piece. 2 to 2 has to reduce to 1 to 1. So calcium gives away 2 electrons and sulfur picks up 2 electrons. That's actually a 1-to-1 ratio. So that's going to be CaS in a 1-to-1 ratio. If you write Ca2S2, you got to say, how does 2 to 2 look to John Dalton? He says reduce it to simple whole number ratios, 1 to 1. In the next one, +3, -3. This is the same problem, but a bigger number. Aluminum must give away 3 electrons. Phosphorus must gain 3 electrons. That's a 1-to-1 ratio again. ALP, aluminum phosphide. Now, Mg and Br. Magnesium makes a +2 ion. How do I know that? Put my finger in the box. Magnesium is 282. It's a metal. It's got to lose how many electrons to be isoelectric to a noble gas? Has to lose 2 electrons. That makes it a +2 ion. It says, take these 2 electrons. Bromine says, great, but I can only take 1 because bromine is a nonmetal and it has 7 electrons in its outer orbital. It can only hold 1 more to be isoelectric to noble gas. So bromine says, I'd love to help you, but I can only take 1. So magnesium says, go get your brother. I'm going to have 2 of you. Mg crisscrosses with bromine. Mg1, Br2. And we don't write the number 1 because we are number 1. Look at this. I got some of the answers for you already. And this last one, sort of the opposite. We got a +1 now and a -2. When we crisscross it, it becomes, we need 2 lithiums to provide 1 electron each to the oxygen, which has to be -2. The compounds are neutral. When they combine, they're made of positive and negative ions, but they have to balance out. The names are easy. Say the name of the metal atom. Sodium, calcium, aluminum, magnesium, lithium, nothing fancy. The second name is the name of the nonmetal. Change the ending to IDE. So instead of phosphorus, it's phosphide. Sulfur becomes sulfide. Phosphorus again is phosphide. Bromine becomes bromide, and oxygen is oxide. All right, we're going to do more because this is fabulous. We're learning how to write formulas and how to name compounds. You guys are doing chemistry. Beryllium is a metal. See how important it is to know where the elements are on the periodic table? You got to get familiar with this, otherwise you'll be looking all day. Beryllium has to lose 2 electrons. It's got a 2-2 electron configuration. If it loses 2 electrons, it becomes isoelectric to helium, becomes a +2 ion. Fluorine is atom number 9. It is a 2-7. It has to gain 1 electron. So 2 and 1 is not even. Crisscross. 1 Be, 2 Fs. Bef2, the little 2. We don't write Be1. It is 1, but we don't write the number 1. Bef2. And of course, it's called beryllium fluoride. Yeah, I'll show you the answers and I'll talk you through these. That way, some of you who got this already can just do quick. Strontium's a +2, chlorine's a -1. Same thing, crisscross. One strontium, two chlorines. It's called strontium chloride. SR, we don't write the one, SrCl2. The 2 is a subscript. It's not squared. Don't put it up in the air. It comes down to the bottom. Here's a good one. We have a positive 2 barium. Barium is number 56. It's in group 2. And nitrogen's way over here in group 15, makes a negative 3. So we get a positive 2 and a negative 3. And when we crisscross them, it's going to take 3 bariums to connect with 2 nitrogens. Now let's think about this before we go on. If barium's a positive 2, it can't hook up with a negative 3. 2 and 3 are not the same number. But if we have 3 bariums and they're all positive 2, that means 3 bariums are going to give away 6 electrons. Now the nitrogens gain 3 electrons each. We have 2 of them, 3 and 3, that's 6. So 6 barium electrons come out and nitrogens pick up 6 electrons. It's a perfect transfer of electrons. And the only formula that will work is 3 bariums, 2 nitrogens, Ba3N2. That's how you read this formula. Ba3N2. And it's called barium nitride. That's the simple whole number ratio that can't be reduced. 3 to 2 cannot be reduced. This next one's really easy. Positive 1, negative 1. That's like sodium chloride. Potassium is underneath sodium, number 19. Iodine is underneath bromine in group 17. Positive 1, negative 1. Potassium transfers 1 electron. Iodine says, great, that's all I need. They go together in a 1-to-1 ratio. Ki, potassium iodide. Kind of like sodium chloride. Group 1, group 17, 1-to-1. This last one, aluminum, element number 13, has to lose 3 electrons, and oxygen has to gain 2 electrons, and 3 and 2 are not the same. We have to crisscross, and we're going to need 2 aluminums and 3 oxygens to balance that. 2 aluminums give away a total of 6 electrons, and 3 oxygens, 2, 4, 6, they pick up a perfect transfer of 6 electrons. Aluminum oxide forms Al2O3. This easy way to do it, called crisscross. The numbers from the ions crisscross, but the ion charges are one thing. When we write the formula, we don't put positives and negatives ever in the formula. We don't write ones ever, like potassium iodide, K1, I1. We don't say ones. We are number 1. SrCl2, 1 strontium, 2 chlorines. We don't write the number 1. Simple whole number ratios. Think the crisscross method. This is how it works. Al is a +3 and O2. How does this work? Oh, I was going to crisscross it. I don't have any of the designs. 2 aluminums give away 3 + 3. That's 6 electrons come out of the 2 aluminums, and the oxygens gain 2, 2, and 2. All right? I would draw you a nice big picture, but you're not here. You're in Zoom. I don't even know where you are. Who knows where you are? Who knows where I am? Actually, I'm in a classroom. Okay, you can do this already. Name these compounds. Now, I'm going to take a second. You're going to hit pause. See if you can name them. The answers are on the next slide. Hit pause and say them out loud. I'm not even kidding. Do not cheat yourself. Don't say, I could do this. Say them out loud. That way you can see. Now, nobody's going to hear you. This is actually great. Usually I have to pull people like, you, say this one, you. Put it on pause and say the name of all these compounds in order so that when we see the slide in the next one, we'll see if you got them right. Okay. All right. Lithium chloride, cesium fluoride, beryllium oxide, magnesium sulfide, magnesium fluoride, calcium phosphide, lithium phosphide, sodium nitride, and aluminum sulfide. The rule, say the name of the metal first, the atom name of the cation. Don't change the name. Table S, perfect names. The second name for the non-metal, you change them all to end in IDE. Now, who's this guy, Harpo Marx? Anybody know? I love this picture. Harpo Marx is a funny guy. There were 4 brothers, 4 Jewish brothers from Brooklyn in the vaudeville 1920s, 30s, and 40s. They made a whole bunch of silly movies. One brother made believe he was Italian, talk a little like me. This guy made believe he couldn't talk at all. He would blow a horn and just pantomime. One brother His name was Groucho. He had a fake mustache and fake eyebrows, and he'd walk really crazy, and he was crazy, silly. And then there was another brother called Zeppo, who was what they called the straight man. He wore a suit and tie, looked really nice, and he would help set up the jokes. But these four guys, these four brothers, they made a whole bunch of movies, and they were funny as heck. But Harpo, he would never talk. Speak. Don't be afraid to speak, right? Look these guys up, the Marx Brothers. You want to see something really funny? Look up the Marx Brothers mirror scene. There's a famous scene in the movie where Groucho Marx is chasing Chico Marx, and then Harpo jumps in at the end. Very famous scene. All right. Near the end of this slideshow, a couple of minutes here. The compounds formed when the ions bond together are called ionic compounds. You get ionic bonds, they make ionic compounds. They have ionic bonds, and they have super strong bonds. Ionic compounds like sodium chloride have a very high melting point and super high boiling points. If you put sodium chloride, a big batch of it in a frying pan, you could put it on your stove, you could have some nice hot salt. You never melt it. They don't melt until like 3, 4, 5,000 centigrade. High, not like ice. Ice you can melt in your hand, right? Forget about it. This stuff will not melt or boil, can't do it in the kitchen. Ionic compounds only form when a metal atom can directly transfer to a non-metal electrons, and it has to be perfectly balanced, right? If you only have one calcium and one chlorine atom, you can't make calcium chloride. You got to have 2 chlorines, got to have a perfect transfer of electrons. There are no loose electrons. There's no IOU electrons. I'll give them to you later. The transfer of electrons must be perfect. And that transfer of electrons being perfect is what causes the simple whole number ratios that the compound formulas have. Whew. Ionic compounds. We just covered monoatomic, meaning periodic table, atoms of metal and atoms of nonmetal, the monoatomic ionic compounds. Now there's 2, 4, 6, 8, 10, 12 metals, 13 with aluminum that we've talked about, and there's about 10 nonmetals. So we've got 13 times 10 combinations, almost 1,000, maybe 1,200 possible combinations you now know how to name. You now know how to write the formulas for. It's pretty cool. 20 minutes with me. Tonight, got to read the basics, all right? Basics. Don't worry about that homework. That's from an old slideshow. I don't even know what the homework is yet. Read the basics. Listen, it takes some familiarity with the periodic table. You don't want to be looking all over the place. Metals lose electrons. I told you group 1 metals lose 1 electron. Group 2 electrons lose 2 electrons. Aluminum loses 3 electrons. On the other side, the noble gases are the models for the perfect orbitals. They don't lose any electrons. Group 17, fluorine, down, they gain 1 electron. And group 16 down, they gain 2 electrons. And then nitrogen in group 15 and phosphorus and arsenic, they gain 3 electrons. There's a lot more elements in the middle of the table, a lot more atoms. We'll get to that, okay? We'll get to that. But we covered group 1 and 2, and 18 doesn't make ions, and then 17, 16, and 15 on the top. There are other atoms, and there are some other things going on. We'll get to it. We can't get everything the same day. There's a lot. Chemistry is a really big class, right? We still got a lot of time. You can do this. Read the basics. Thank you so much for playing. Thank you so much for doing this. Goodbye.